Okay, all right. So the next topic is exception handling. So first of all, what is an exception? So let's just say you are trying to execute some task, 7 divided by 0, something like that. Okay, you got some error message. So basically, a exception is any unexpected event that occurs during program execution. Okay, for example, when we try to divide by 0, we know it is not divisible, but we still try, and some error, we ran into an error. So this unexpected event that instead of getting the result you got some error, that is called as exception. Okay, now exceptions will happen at runtime. Okay, um, so which means when you type the code there is no fault in syntax, only and only you execute the code. Okay, let's just say I type the code here. Okay, if I type the code, no error will be displayed, but only if it is executed then you get the error. That is, exceptions are received at runtime, that is why we say runtime. Okay, and second thing is, sometimes when some illegal operations are performed, okay, then also you will get exceptions. Now we will see what are those operations that trigger a exception, but just understand that exception is something that has to be handled in a code. For example, another example I can give you, if you're trying to open a file, let's just say with open some file, okay, it does not exist. Okay, but I'm trying to open it in read mode, and the file name is um, does not exist file. Okay, dot txt, some file. Okay, as if, and then if I try to open f dot open, okay, so I get file not found error. So the file itself is not exist, but we are trying to open it. So such operations, okay, um, are called as exceptions. Okay, these are some of the examples. And also import error. Let's just say if I try to import PyArma, I have not installed PyArma, hence I can't import it. Okay, if I have to do import this, I have to do a pip install. Otherwise, I won't be able to install access this. So such errors are known as exceptions. Now there is a way for us to look at what are those exceptions. We already know dir, okay, and we already know built-ins. Okay, built-ins will give me the list of all the built-in functions that are available. These are all these are all the built-in functions available for us to use in Python. Okay, and many of them we already have used, right? We have used false, we have used none, we have used true, we have used a lot of them, like apps is used to get absolute value, that I have not shown you, but nevertheless it's there. And ASCII we used, any we used. Okay, callable, I think callable we didn't use, but anyway, dict we used to create a dictionary, right? So dir we already used, now just now we used. Okay, um, and then here format we used to write a formatting. So a lot of this input id int is instance, so a lot of these methods we have already used, right? Now there are certain other sets of methods also. If you notice, they are ending in error. Okay, some exit, some error, something like that. These are all part of exceptions. Okay, now to get only exceptions, what you can do is you can type, okay, locals. If you type locals and put this as a um, key value kind of. Now you got only the exceptions. Okay, now even now it is giving you the complete list. Anyway, locals it's giving you. Hmm, Never mind. So just remember that anything ending with error, okay, is a exception, and those exceptions have to be handled. Okay, and in order to handle, Python already has done a lot of heavy lifting for us. It has already built in methods. We just have to call them, and we need to know when to call what. Okay, that not all, but some of those I will talk about, and we will see how to catch an exception, and then raise an exception. Okay, those are the only two things we will look at, and those two things are the most used ones. 99% of the cases you will be doing that only. Okay, all right. So um, the next thing is we have try and except, right? So exception handling, way, the way how you handle the exception is to try executing the code, right? So I directly divided 7 by 0, but had I used this try, I'm saying first try to execute this code, okay, and check if it works. If it works, okay, I'm gonna say 7 divided by 0. I'm only going to print it, the result. Basically I want to print the result. Okay, if it works, well and good, it will print. If not, I'm saying except if it doesn't execute, raise. Okay, division error. Okay, okay, you got division error. It raised a division error. Okay, type error, fine. Still you are able to use this try, but what if this was 2 here? So if the code executes, the code will be executed as part of try. So first try will try to check if the code is executable. If it executes, it will execute the code and stop it. It will print the result and stop it. If the code is not executable, the control will go to except. Now in except, you can either print or raise a message. Here I have raised, but here I will just print. Let's see. Okay, so okay, so this is 2, that's why it's working. And what if this was 0? So now it knows the code can't be executed, hence it has printed division error. Okay, so in order to handle, basically the what I'm trying to explain you is, in order to handle all these exceptions, we use try and except. Okay, try will, upon successful execution, try will do, the code inside try will be run. Okay, and if at all there is any exception, it will be caught in except section. Okay, is this clear? Try and except. Okay, so for this case I'm only printing here division error, but what if I wanted to catch that division error? So I would say except 0 division error is already defined for us. Okay, so I will catch that error, and then I want to tell the user that they can't use 0. Hence I would say denominator must be non-zero number. Okay, now see what happened. We caught that exception and we gave the message to the developer or the user stating that you can't use 0 as a number, as a custom message basically. So try and accept, either it can accept means it will automatically catch, it knows it's a 0 division error. But what if some of those errors, new errors, are not handled anywhere in this section? Okay, in that case you don't have to specify. Okay, so you can simply add a print message. If you know what kind of exception is going to be uh, present, you can ask the interpreter to catch that exception, print. Both are one and the same, so if you add the same message there also, it will work. This is more like a general form. This is more like a below one is like more like a specific form. This is specifically we are handling. Here we are just telling we don't know what exception it is. You only go ahead and catch it and just give me this message. That's the difference. Okay. All right. So to this try and except, we also can additionally increase our functionality by adding a else clause. Okay. In else clause, just like when you used loops, right, you also had a else clause. Okay. So when you handle else clause, you can print your own custom message. Okay. Try again, or you can even execute some code. Okay. um, let's just say I okay, num is for numerator, den is for denominator. Okay, here you can try something like uh, den, because in this case denominator was 0. Okay, here let me replace these values, num, and this is denominator. Here because denominator was 0, we are going to do one thing. D is equal to d plus 1. We don't want to get the zero division error itself. Instead, if whenever denominator becomes 0, we will make it as 1, and that way we will get the same value that was there in the numerator. No need to even uh, no need to worry about the exception. Denominator changed to 1. Okay, you see what happened? This exception was caught here. Okay, that's why this section is printed. But let's just say I will not catch that exception. I will only print okay, I think it will still be caught. Okay, let me try. Okay, okay, you noticed, right? So in case uh, one thing is clear, so if you add except, that exception will be caught. But let's just say you don't want the exception to be caught. Instead, you want to write a logic in such a way that this will be executed, but on top of that, okay, you also want to write additional logic. After you execute this, you want something else to also be executed. Okay, that then you can use the else clause. So the point here is, if except is not executed, then else part will always be executed. Okay, when you used for loop and then else loop, right? So you notice that irrespective of what happens in the for loop, else loop was executed. Very same to same. If try part is executed, else part will always be executed, except when except part is executed. Is this clear? Or maybe I can show you with another example. I will just simply say try. Okay, we will accept a number from a user. Okay, we will just say enter a number, and once you accept the number, okay, we want to make sure that the number is divisible by 2. So I will add assert. Okay, I will explain more about assert, or you can just ignore assert for now. I will talk about it when we do it. N mod 2 equals to 0. So basically we are checking if n mod 2 equals to 0, we are gonna print even number. Okay, and except we are saying, except we are saying print, if that first condition fails, okay, you print not a even number, not an even number. And after both the conditions are evaluated, either the above one or the second one, you finally do this thing. Okay, you do some sort of calculation. Maybe here I'm just taking reciprocal 1 by n and print reciprocal. Okay, you enter a number 5. Okay, you got 0.5. What is happening here? So when you entered a number 5, this condition failed. So it didn't go to this condition. It was supposed to catch an exception, but there is no exception to catch because 5 is a valid number. Okay, 5 is a valid number, hence there is no exception to catch. This part is not executed. Hence, else part is executed. Reciprocal is taken and printed. Okay, but if I had accepted a number, okay, and tried to accept a number in such a way that uh, 0 mod 2 is also 0. Okay, let me try once again. 0 I will pass. Okay, here what happened? 0 mod 2 was tried to evaluate, so this condition failed. Now uh, a exception was raised. The exception was, okay, 0 divided by 2. Anything divided, 0 divided by any number is 0 only, no? Why did this condition fail then? Okay, here else part, yeah, else part the exception has been raised, correct. So if I pass 0, there is no exception to catch here, hence it lets you through here. But in the else part, because I'm taking the reciprocal, 1 divided by 0, num value was 0, hence 1 divided by 0 became an exception. Exception has been raised. Uh, okay, but uh, if I write it in such a way that this exception should be caught, in, okay, fine. Else, here also I can add try. Else try this, okay, except, okay, except try this and print this. Okay, print this, except I would say print num can't be 0. Okay, now you enter 0. Okay, this condition is met, that's why it's printing this. And because this try part is executed irrespective of what happens in try part, else part will always be executed. Okay, just like your loops, else part is the behavior is the same everywhere. So hence it will try to execute this section. It is not executing this because there is no exception here to catch, but there is exception here to catch. So it is executing this part, it's checking the reciprocal, this condition, this condition raises an exception, hence that exception is caught here and we are printing number can't be 0. Okay, is this clear? Try except else part, have you understood? Okay, okay, all right. The next thing we will see is, okay, I have added the syntax here, I think. So try and except part is, you just do the operations. If there is exception, you catch it. Okay, or if you want to catch another exception, you catch it. And then if there is no exception, then you execute this block. Okay, that is the try and except and else section. Now finally, section, first of all, finally, section is optional. Okay, But when you add finally, even if you don't add finally, you see you can execute the code like we have tried done here. But if you add finally, so this will always run regardless whether there is an exception or not. So that is what the thing is. Okay, let's see. Try once again, we will say try numerator equals to 10. Okay, denominator equals to 0. Okay, and result we want to try with num divided by denominator, and then finally print the result. This is our try, this is what we want to do. Now we are saying we know an exception will be raised, hence we are saying except print. We don't know what type of exception is raised, hence we are not specifying. If you know, you can specify there whether it's a zero division error or whatever. If it's a different thing, you can specify there. If you don't know, just leave as is. Then you print the same thing that we did previously. Denominator can't be 0. Okay, then can't be 0. Now that try and accept the, up until this point is fine. Even if you don't specify finally, this code is fine, it will run. But if you want to specify finally also, after you specify finally, and you will add something in finally. Okay, um, end of execution or something like that. um, you see, end of execution is executed. Okay, irrespective of um, whether the try or except ran, one of these two runs, right? Always either try runs or except runs. Fine, in either case finally will always run. Okay, but else is not like that. Else will run only if try completes, successfully runs. If try completely executes, else will also successfully execute. If try fails, else the control won't even go there, so it will only execute the except part. But finally is different. So try part or except part, finally part will be executed. Okay, that is the difference. Here except part executed, then in spite of that finally part executed. Okay, is this clear? Okay, now let's come to, okay, okay, very good. So now let's come to very important part of this exception handling, raising a exception. Okay, how to know raise a exception, that you must know when you write a logic, when you write code, right? I'm sure most of you are already aware as a developers that when you write code, some exceptions have to be handled by yourself. Now how do you do that is what we are going to look. So we have something called raise. This is a Python keyword. So this keyword has been provided for us so that we can raise any error. Okay, we will see one with a simple example how to raise error, and accordingly that exception will be handled. Okay, all right. So in the same example, okay, num is equal to 10, denominator equals to 0. The denominator 0 is caught, but I will add, modify something like this. I will add, I will import math. Okay, you will see in a minute why. Okay, so now I will say, okay, so math dot infinity, I want the denominator to be infinity, but I know the result is going to be 0. Okay, yeah, ideally it's not 0, it's 0.00000, it goes till infinite. There is no exact value to this result. Any number divided by infinity is not 0. Okay, ideally it's not 0 because there is no definite value for infinity, right? But what I want to do is this, because this is not raising an exception. See, this code is working, it's giving me result, but I don't want this math dot infinity to be the denominator. As soon as someone gives this denominator as math dot infinity, I want to raise an error. Okay, saying math dot infinity should not be used. So how do I do that? Even before printing the result or even before doing the denominator calculation, I want to check if then equal to math dot inf. Okay. Um, okay. You can say raise then cannot be inf. Then you don't try this. Okay. If that is the case, okay, you can add another additional try and accept here, but for the sake of showing you how to use raise is what I'm gonna show you. I'm gonna hash this and also this. Okay. It raised n can't be infinity. Why didn't it work? uh, okay. Okay, fine. So I think it's not taking a string. Okay, let me try something else. I will define a exception class. Okay, a class with uh, check if inf. Okay, and I will use this exception as a base class, exception as a parent class, but that exception also should be a separate class because I'm inheriting the properties, right? Okay, so in Python everything. Okay, let me check something fast. First of all, this exception import. um, One second. One second. I will check. Where is my base class? Zero division error. Okay. Exception exists. Okay, exception exists. Fine. If exception exists, then if I do dir of exception, okay, okay, fine. Now I can use it. Okay, so in order to handle this, okay, so ideally you should be able to raise and get the error, but anyway, so for string it's not working. But the way how you would handle this is by defining your own class, by calling it as a exception. Now exception by default Python provides this as a base class of errors. Now base class is, as we have already discussed in multiple and multi-level inheritance, that base class is a super class from which all other derived class comes. Okay. So if you define this class as some check if exception, I'm not even going to do um, write the logic for this, but I'm just going to pass it for now. Now that I have just passed some value, um, I will put this here. Okay, raise. I'm saying I'm creating my own class, and I'm saying raise denominator cannot be infinity as a error message wherever the condition meets. um, okay, and then I'm just doing pass. Okay. Okay, not raise. Okay, for now, just ignore this part. Just add a pass value here. Now I'm checking my denominator. I'm setting this denominator equals to mat.inf. Okay. After I execute this, now I wanna try. Okay, here I don't wanna set it. Instead, I wanna try. My number is 10, and here I want to check if number equals to mat dot infinity. Now I want to say raise check if check if INF. Okay, then I want to say after you check, okay, else, okay, you print, or else part is not needed for now for simplicity, except you do this. Okay, I wanna handle this as this denominator can't be 0 or infinity, and then finally you print end of execution. Okay, okay, denominator can't be 0 or infinity. Okay, this exception is handled. Okay, fine. So when you want to raise, ideally I have seen raising, I myself have raised some error as a string value. Okay, I don't know why it didn't work, but anyway, maybe it will work under except here. If you don't print, maybe it will, you can raise except raise as some value you can print. That also we will see as a second version of it. But for now, just understand that if you are going to use raise inside try block, okay, in this case I want to check if denominator is math dot infinity, and in that case I don't want it to be infinity. So for that I have created some class, okay, and I have defined it as an exception. Now this entire class became exception. It inherited all the exceptions that are available in exception main base exception class. And what I'm saying is, except you raise this error. If that is the case, you just raise this error and print this message. Hence that message is getting printed. This is how you can catch a exception. Okay, although this was not an exception in our case, but still we converted it into an exception and we are catching it. Okay, so that is what the result is. This you could have also handled check if then equals to um, or maybe check if then is not equal to mat dot infinity. Okay, you can add a pipe, or you can add a or then is not equal to a 0. Only in that case, okay, you do res equals to numerator divided by denominator and print the result except this exception and except another exception that we already saw called zero division. I am either you know the name, you specify, or else you leave it. Denominator can't be 0, can't be 0. Here I will add 0, here I will add infinity. Okay, okay, did I miss anything? Okay, I failed to raise, right? Except line number except must be last, default except must be last. Okay, fine. Okay, default except must be last. Just okay. So this okay, this in this case it was not handled because we didn't raise it here. Okay, if it is not equal to mat dot infinity, but let me check what my den is now. uh, Den is, I think, infinity. Okay, if it is not infinity, we are saying only then you execute this. Okay, but in this case it is infinity, hence this part is entirely, ideally it should have been skipped. Why is it executed now? Because it's not exception. Okay, it's not okay. Okay, let me change the condition itself, or then okay, fine, I'll have to raise it here. Raise check if infinity. Okay, okay, Now you are able to raise it. Okay, so you can raise it in try, but if you want to catch it in, um, if you raise it here somewhere else, if you want to raise it somewhere else, you can directly pass with a string. Let me check if I can get some relevant example. I will show you. um, let's just say 7 divided by 2. um, first okay, first do the math. Okay, 7 divided by 2, um, is equal to 7 by 2. Okay, then if, again we are raising it in if condition only. Okay, anyway, if I get an example I will show you, but you can raise this exception along with a string. So you don't always, under except especially, you don't always have to call a exception class. Here this is a class, right, which we defined. You don't always have to do that, but instead you can raise the error also. Okay, that you, if you find an example, you can explore, or else if I find an example, I'll let you know. Okay, but this is how you catch exceptions. Up until this point, is it clear? Try, except, finally, try, except, else. Any doubts? Exceptions must derive from uh, named class. Anyway, fine, don't worry about it. So if you have understood this, then you can go ahead and raise your own exceptions by just defining a class and passing this base class as um, a parent class for this, and then you can pass it, use use it by raising the exception. So here, although it was not an exception, we created a exception and we are raising it. And that you can apply in your coding. Okay, if this is done, then we will move on to the another topic. Okay, um, now our next set of topics are quite interesting topics. Next is, I will talk about random module. And random is very kind of enjoyable kind of work. Okay, so as the name suggests, random module is used when you wanna. Okay, one moment. I also have to show you assert, right? Yeah, assert also I have to show you. I didn't show you. I'm sorry. Okay, all right. So assert, the keyword assert. If you type help of assert, okay. Uh, is am I typing wrong? Okay, fine. Assert I will show you anyway. So assert is mainly used for assertion errors. Okay, assertion errors. Now what happens is, see, sometimes the program has to wait for a crash. Okay, which means if there is any error that is not caught, syntactically it is correct, but it is not an exception. It is not caught also in the code. Okay, so But if some value, due to some value, some error occurs, okay, that has to be checked first. Okay, that check we do using assertion to avoid any errors. For example, let's just say you have a function wherein which you are trying to convert some Kelvin to, I will type K to F, Kelvin to Fahrenheit. You are trying to convert some temperature. Okay, and in this, you want to check if temperature that you have accepted is greater you have to make sure actually that it is greater than 0. Okay, the reason why that is in Kelvin 0 degree is the lowest temperature possible. Okay, it can't be lower than that. So Kelvin to centigrades, the lowest possible temperature is 273 point something, some 3 degree. 273.35 degree is the universe's lowest possible temperature, and that equates to 0 Kelvin. So basically we need to check here that temperature should be greater than 0. It can't be less than 0. That is not possible, that temperature. Hence, syntactically it is not an error, and it is not also an exception. Okay, if you type temperature greater than 0, temperature for interpreter is just a variable, but for us it holds some value, right? So that is when I want to check assert temperature should be greater than 0 only. Okay, when I type that assert, it ensures that temperature value is passed as greater than 0. And with that, after asserting, you can also pass a message saying that this temperature is colder than absolute 0. Absolute 0 is your minus 273.35, which is your 0 Kelvin, and the temperature can't be less than 0 Kelvin. Hence, you're going to return temperature. Now you are actually trying to do the conversion part. You're trying to convert temperature, okay, which is your minus 273, okay, 0.35 I will ignore, or you can add that also, okay, um, into 1.8. The conversion is done like this, plus 32. So you have to calculate, subtract the temperature minus 273 into 1.8, then you have to add a 32. Okay, so this is my K2F. Now if I call that K2F of, let's just say, 273.35, I have to get 32 degree in Fahrenheit. 32 degree Fahrenheit is same as 0 degree centigrade, is same as 273.35 Kelvin. Okay, both are 0 degrees ice formation temperature. Okay, so this is how you can ensure the temperature value is provided than greater than 0. Now you can test that also. If someone provides you this value as -1, immediately assertion error is raised along with the message that you gave. Okay, assertion is raised and message is passed. This is another way. This is another way of catching the assertion errors. Is this clear? Assertion error you raise when you want to, when there is no error also, there is no exception also, logically there is some fault. Okay, so that is when you assert it, you ensure it. For example, another example I'll give you, practical example. Let's just say you're working on some environment, Azure, GCP, whatever. You forgot to define a project ID. Project ID equals to, it has to be something, but you forgot it. Let's just say it had to be um, some Sadiq dash Pasha dash 1055 or 1077, something like this. Project ID was supposed to be this only. That is when I will say, boss, you assert this value. So after I define this, I will assert project ID first. Okay, if you assert project ID, the program will make sure project ID is equal to this only. Okay, or whatever the condition you pass. In this case we are passing the condition, right? So assert project ID if project ID equals to this only. equals to project id. Okay, if not, pass a message, uh, whatever you error message in professional environment has to be professional, but here I just say you can't use different projects project id. Okay, something like that. I will print a error message when this is not the value. Okay, let's just say this is what it was supposed to be, but I passed some other value. Okay, immediately I got error message saying you can't use hello, you have to use this one only. This is your project id, you can't use some other project id. Okay, that is when you can use assert. So the moment someone tries to use a different project id, this code will fail. Okay, you have to stop the execution from malicious people, right? So that's what assertion is. How this is how one way of using the assertion. Is this clear? Hmm. Right, right, right. Correct, correct. See, assert method. See, you can hard code here, right? But we define certain values are very sensitive, right? So like project id, location, your keys, right? Secret keys that you use, all those are part of environment variables. They come from either configuration files or environment variables. They come from somewhere else. Now let's just say there is someone, some new guy in your team, or for the sake of easiness, let's just say some junior person, or somebody who didn't know, try to run the code project on some other id. Okay, now the problem is, if they use different ids, they'll be able to execute the code, because at the end of the day all projects are billable projects, right? So say very similar services might be running. I'm just trying to come up with a scenario here, okay, to explain you. So nobody, first of all, nobody does a hard coding of these values. If you are doing hard coding, then you have to stop it immediately. Okay, that is only allowed in the development environment, not in your testing environment or prod environment. Prod environment is definitely not allowed. Okay, but only in development or experiment stage people hard code. So that hard coding has to be stopped. That is one. Second thing is, if somebody likes to check, likes to ensure that certain variable carries the same exact value, okay, without hard coding again, then they can use assert. So someone tomorrow, if try to execute the project, the same code on a different project ID, some other people will get billable, right? They'll be billed. Given a scenario that a person works on multiple projects and has access to multiple project IDs, so in that scenario, um, so some other project will be billed. So in such cases, you can always assert the values to ensure those particular variables carry those exact values only, not no other values are allowed. So in such scenarios we use assert. Mhm, mhm, mhm. Correct, correct, correct. Yeah, we can't change that value. It will ensure that this carries this exact same value. Okay, that is what. And raise also, I got, I think I was making one minor mistake. Raise also, you can raise either by defining a base class, exception class, or you can call the exception class directly. For example, x is equal to 10, let's just say, and if I want to check if x is greater than equal to 5. Okay, I want to ensure that x is x greater than 5. When it becomes 5, I want to raise exception. Okay, if I raise exception, this is what I was typing directly. I was typing the error message. Instead we have to call that exception base class exception, raise exception, followed by whatever the message, x should not exceed okay, exceed 5. Okay, so something like this you can add. Okay, this has to be okay, something like this, and you will get the exception raised. Basically, raise can be used to raise an exception wherever you want, either in try except block or outside that block or in a loop. Okay, sometimes loops also use this raise. Wherever you want, you can use the raise, and if you want to assert a value, you can assert the value. Okay, is this clear? Mm-hmm. Yeah, correct. So you can pass whatever the value you want, you can print that value. So this will be helpful when you run a pipeline. Okay, it may not make sense much on Jupyter notebook. Okay, because here you, this is all you're seeing, right? But if you're working on some pipeline, if you are someone whose job is to understand what triggered that error, and if your job is to write conditions, almost catch all the various conditions, then in order to catch an unseen condition, you can use raise exception if so and so thing happens, so that way. And these logs will get printed. You will get this custom message printed in the log of the pipeline, and immediately you can see this and understand what failed, right? Instead of completely relying on the error message given by the pipeline itself, the default ones, where sometimes you won't even know, sometimes the code will execute, you won't even know what caused that error. You have to break your head going back to the code and reading through. Instead of that, you can keep on checking in your code various ways it may fail, and keep on raising exceptions. Okay, if this happens, you raise this. If this happens, you raise this. If this happens, you raise this. That way, when it fails, you immediately know what caused that error message, and you can catch it. Is this clear? That's all about exception handling, very important topic. I would request you to please practice this. Okay, and this is going to be extremely helpful. There are many types. Okay, like we saw here, right? So there are a whole bunch of them. It's because we are learning data science, so that's why I'm not really going too much in depth. Okay, um, there are various ways of how a code can fail, but ultimately 99% of the cases can be handled with only what we have learned: try except else or try except finally, along with assert and raise. But there are yeah, there are many others. Okay, definitely there are lots and lots of things are there, but yeah. Okay, all right, if this is done, then we can check the random module. Okay, now do you want to take a 5 minutes break and come back, or do you want to continue? um, Maybe I think it would be better if we take a 5 minute break. It's 11 o'clock now. It's 11 o'clock. Hmm. Let's do one thing. Random module. We started at 8, right? Okay. Okay, let's stop the class here. Okay.